All right. A rectangular tabletop made of maple wood weighs 43. Here we go. Pounds per cubic foot. What did we talk yesterday? What's that 43 representing then? That's my density. Mass per volume. That's my density. But here's the catch today. And we have to start being disciplined about this because we weren't yesterday because it didn't matter yesterday. Pounds per cubic foot. Look at the tabletop. Look at the dimensions of the tabletop. See anything interesting there? The density was pounds per cubic foot. Notice anything about my tabletop? Length of 8 feet, width of 3 feet, a thickness of 1 inch. That's a problem. You have to, all the units need to be the same as your density. So if my density's in feet, so do all the dimensions of my figure, which it's not. So before we even find volume, we need to make sure all these are in feet. All right, everyone good here? They have to match the dimensions of the density and your figure. They both have to be the same. If they're not, you don't do a darn thing. Right away, you change all of them to the same units. So it's got to be feet, feet, feet. So I got to change 1 inch to feet. All right, how do I do that? How do I change 1 inch to feet? I could, hold on, I could set up a proportion, right? 12 inches equals 1 foot. I have 1 inch. How many feet is that? Or if you know what to do anyway, you don't need to set up a proportion, right? So you set up the conversion, put what you need underneath, make sure all the units stay on top of each other, and then you can cross multiply. And what you end up doing is dividing by 12. You get 12x equals 1, x equals 1/12. All right, so instead of using 1 inch, we're going to use 1/12 of a foot. Your density has to be in the same units as your object before we do anything. All right, now that I have everything converted, now I can break out my density formula like we did all yesterday, mass divided by volume. Plug in my 43 for density because you guys told me that's density. What's the weight of the tabletop? That's my M. And like we did yesterday, now we'll go off to the side here and calculate the correct volume of the tabletop using the 1/12 now. I cannot use the 1 inch. They have to be all in the same units. So I'm going to multiply 8 times 3 times a 12th. This is going to be the toughest part for us today, making sure they're in the same units and converting them to the same units. So we end up with what, 2 cubic feet? Plug it in for your volume, 2. And your mass ends up being 86. What's my density in pounds? So this is in pounds. There we go. 86 pounds for the tabletop. Again, I don't care if it sounds like a broken record. Your density and your object have to be in the same units before we do any calculations. Any issues here? This is just basic. All right, next one. This next problem is not a density problem, but it is a change of units problem. All right, you guys see what we have here? He can mix his own concrete, $3.25 per cubic foot. It's not density, right? Because it's not mass over volume. It's not density. But anybody see the issue? I'm going to charge you per cubic foot, but look at the diagram. The diagram is in inches. So before we do anything, we need to convert these to feet. All right, Watt, go ahead.
Would you be able to convert it at the end?
No, I don't want you to convert it at the end. Okay, because here, and just a quick explanation why, Abbott, is when you find your volume in inches, it'll be in inches cubed, and I can tell you 12 inches cubed is not the same as 1 foot cubed. So that's why I don't want you to do that. All right, I want you to do it right away. All right, because that will not work converting it at the end. All right, so let's convert 36, 36, and 4 into feet for me. See if you can do it. If you need to set up a proportion, 1 foot equals 12 inches and do it that way, go ahead. But convert them into feet for me. And we understand why I need to convert them into feet, because we're charging $3.25 per cubic foot. The 36, everyone, 36 should be going to 3 feet. All right, that should be converted into 3 feet. Since there's 12 inches in a foot, 12 goes into 36 3 times. And the 4 inches, you should convert it into 1/3 of a foot. Don't leave a repeating decimal, leave it as a fraction. 1/3 of a foot. Next up, it is per cubic foot. So that's how I know I'm going to do volume of this concrete section per cubic foot. So 3 times 3 times 1/3 for my volume. And there's one other trick here. I don't know if anybody's noticed it yet. So the volume will be 3 cubic feet. Before I move on, anybody see it? I didn't read this part to you, but there's another. Before I even deal with the money, what's up, brother?
So there are like 2 of them?
Yeah. Ian to replace 2 concrete sections that are both the same. So 3 cubic feet times the other one, right? I'm going to end up with 6 cubic feet of concrete, right? Because it says the 2 sections. All right. Can you find out how much I'm going to spend now? $3.25 per cubic foot. If you, again, ready? If you guys are worried, what do I do with that $3.25? Do I multiply it by 6 or divide it with 6? Write your proportion. $3.25 for every 1 cubic foot. There's your ratio. If you don't know what to do, and again, I don't need to see this. If you know what to do with the $3.25, go and do it. But if you don't, if you're on the fence and it's 50-50, set up this proportion. How much money is it for 6 cubic feet? And then you'll notice right away, hey, I got to cross multiply. And what are we spending here? $19.50. All good? We're starting to see change of units here. All right. If you're wearing socks, tighten them here, pull them up because you're about to get them knocked off here with this next problem. Whew. There you go. Buckle up. Tissues are back there if you need them. All right, we got a snow cone. It's a cone and a hemisphere. I gave you all the dimensions you need up there. There's a lot going on here, guys. A lot going on. Density, 0.697 grams per centimeter cubed. Stop. I don't even care what the rest of the problem says. Do my units match? Do my units match the object? Whew. At least that's one thing we don't have to do. We don't have to convert. If you're wondering how I know, centimeters cubed, and it's in centimeters. We're good. We don't have to convert. All right. If we did, I want it done now. Don't wait until the end of the problem. Convert the units now if they need to. The cost per kilogram of ice is $3.83. Look, how much ice is it going to take me? How much ice? What's the price of the ice for 50 snow cones? 50. All right, let's take our time. I have density right here, and they're going to charge me for the mass, $3.85 per kilogram. First thing would be good to find is how much does this bad boy weigh? One cone. I know I'm doing 50, but one cone, how much does it weigh? What's getting plugged in for density? Now I got to call on you guys here. 9, what's getting plugged in for the density? There you go, 0.697. Mass I'm finding. All right, get those calculators cranking and formula sheets out. Volume. The volume here. What's on top? What's that figure on top again? 9. What's the figure on top? That's half a sphere, right? So what's the formula for a sphere? Pi r squared cubed. And then I'm going to divide that by 2. Yep. Plus, what's the figure on the bottom? 13. Figure on the bottom, Charlie? That's a cone. You got the formula for a cone for me? 1/3 pi r squared. All right. There's going to be the volume. Times the height. Thank you. Times the height. All right. I believe you guys should be able to find the radius and the height pretty easily there. Don't use 8.3, but go ahead and calculate the volume of a cone. Make sure you cut the volume in half of the hemisphere. I'll leave my volume up here so everyone can check if there's an issue. We all good? Everyone can get that volume. I can move on. All right. Let's plug that back into the density formula. And let's find the mass of a cone. I got 232 because we're not done yet, so I'm going to write out all the numbers. This is why this problem becomes a little tougher. Anybody issues with the mass? Here's why it's going to be, this problem's pretty tough. What's this in? Go back to your density. What's this in? The mass. What's this in? This is in grams, isn't it? Got to make sure we're aware that my mass in this one is in grams. But what are they charging me? I don't want to use the 383 yet because they charge me per kilogram, right? They charge me per kilogram. So I need to transform this into kilograms. It's not on your reference sheet. So I told you yesterday, if it's not on your reference sheet, that's something I will provide as well. Here it is. Here's the conversion. If you don't know it, 1 kilogram equals 1,000 grams. Okay, there's your conversion. Again, that would be something in parentheses at the end of the problem I'd provide on the test if it wasn't on the formula sheet, which it's not. Okay, so let's convert that into kilograms. Again, make a proportion. If you don't know what to do with the 1,000, perfectly fine. Make a proportion out of it and make sure gram stays with grams. So I'm going to take the 232, put it under the 1,000 grams, and solve for x under kilograms. Cross multiplying, you'll see, oh, I divide by 1,000, right? How's that look so far, right? All right, what do you want to do next? So that's how many kilograms are in a cone. You know how much they charge us per kilogram now of ice. There's still another piece here we got to worry about, but we can talk about it at any time. What's our next move now? I know that this one cone this is how much it weighs in kilograms. And they charge me 383 per kilogram. You gonna take it?
Yeah.
Go ahead.
Multiply it by 383.
And here's our next step. All right, you want to take care of the money? Sure, let's find the money. If you don't know what to do with the 383, remember, it's 1 kilogram equals $3.83. Is it 83? 383. And again, I don't need to see this if you know just to multiply by 383. Just multiply it then. This is if you're on the fence and you don't know what to do with that 383. We keep the kilograms with the kilograms. I'm not too sure what that comes out to be because I did it in a couple different steps. And then that money you see on your calculator, remember, is only for one cone. What are we looking for? 50 cones, right? So that final answer that you get needs to get multiplied by 50 because there's 50 cones. And that 50, I don't know if anybody you were too nervous to let me know or raise your hand to answer. I could have multiplied this grams by 50. I could have multiplied the kilograms by 50. I could have multiplied my final answer, which is many of you are doing right now, by 50. That 50 can be multiplied at any point in this problem after you find the mass. Okay, at any point you could have multiplied by 50 after finding the mass. And hopefully we're getting out $44.53 for the ice. Okay, so again, that 50, whenever you found the mass in grams, kilograms, or after you found the money for one cone, you can multiply by 50 at any time. If you want to wait to the end, your call. All right? Whew. It's a big one. Questions there? All right, I think I'm going to start one more. I'm going to start number 4 with you, and then I'm just going to let you go on your own. All right, because if you need my help, I'd rather work with you one-on-one than just the quiet group I usually get. So let's start with number 4, and I'll let you finish it. I'm going to start it, and I'll let you finish it. All right, so we need 500 bricks, kind of like the 50 snow cones. We need 500 bricks. You see the dimensions of the brick, and I give you the density. Stop. Anybody got a problem? I do. What's the problem? What's the density in? Do we see what the density is in? Meters. But what's my bricks in? Centimeters. That's a problem. All right, I got to convert it. All right, so I need to turn the centimeters into meters. Objects units need to match your densities units. That's a problem. We need to change it right now. Don't even move on. Don't try to do D equals M over V. We got to change the centimeters to meters right now. Okay, whatever your density in, your object needs to be in. All right, is that on the formula sheet? Centimeters to meters. Or am I going to have to give that one to you? Nope. Okay. Here you go. 1 meter equals 100 centimeters. Okay, 1 meter equals 100 centimeters. So I got to turn every single one of those 5.1, 10.2, 20.3 into meters now. Okay, need to change them into meters for me. So go ahead, if you need to make a proportion because you don't know what to do with the 100, go ahead. And then we'll make sure we're good. 5.1 centimeters is equal to that. 10.2 centimeters. All right, quick check as you're doing it, 0.041 meters, 0.051 meters, 0.102 meters, and 0.203 meters. That's what I get when I convert all those centimeters to meters. And this is where I'm going to let go. Okay, this is where I'm going to let go. They have 900 bricks or 900. The trailer can hold 900 kilograms. Can it hold the 500 bricks? So you're going to have to figure out how much 500 bricks weighs. All right, using D equals M over V. You're going to have to find out how much 500 bricks weighs and see how close that comes to the 900 kilograms, if it goes over or not. All right, I'm going to end it there. You guys know it. You know where the answer key is. I'll be floating around if you have questions. I know these are tough. Don't do it in silence. Let me know, especially number 6. 6 is a beast. All right, so let me know if you have questions, please. It's not the easiest. I get it. I'm here to help you guys.